So again, the summary of chapter 3, which is shapes and constructions. So first thing you should be able to do is you should be able to name an angle with letters. There's a good example here. You see it goes X, Y, Z, like this. So the angle is called XYZ. Y is in the middle. Another name for this angle could be actually ZXY. Depends on how you look at it. And so what they give us is they give us a couple of examples in here. Name this angle, right? So this is obviously, this is a QPZ if we go from the top, right? And the largest angle. Okay, so this is an interesting topic, largest angle. So here we have to know the way to measure angles. And to measure angles, we normally use the protractor. So this one's kind of obvious. Maybe we don't need protractor here because you can see that one of them is obviously smaller than others. So this one, BAC, right? It kind of looks small. Then we go PQR, a bit bigger, and STU, similar to PQR, but even bigger than that. So yeah, this is kind of self-explanatory. So I'll go right to next topic. So you should also be able to classify the angles. And you can see that here we have, this is a right angle which looks like this. Pretty common thing in construction especially, and many things, you know, people that just like how it looks, the right angle. There's acute angle, so the properties of them are like this. Should I write it here? Yeah, why not? So the properties are the right angle, it has a very consistent size. Right angle is equal exactly to 90 degrees at all times. 90 degrees. Acute angle is acute angle varies. So the size can be all the way from 0, but normally it's more than 0, not equal to. Let me make it smaller, maybe 1.5, yeah. So it goes from 0 all the way up to 90, but it cannot be 90 degrees because if it's 90, then it's a right angle. Next one we have is obtuse angle. So obtuse angle is from 90, but more than 90, again, not equal to 90. From 90 degrees to 180 degrees. This is our obtuse angle. Reflex angle is all the way from 180 degrees. Oh, sorry, on the other side. So it's more than 180, and of course it's less than 360 degrees. And last one is a straight angle. Straight angle is equal to 180 degrees. So look at this again, please. This is the types of angles you are supposed to know. It's a right angle, it's an acute angle, obtuse, reflex, and a straight angle. Sometimes there is also a full rotation kind of angle, but it can't really be called an angle, which is 360 degrees. Okay, so now we can look at these angles. We have A, B, C in here, and what we can do is we can classify these angles. I think I'm going to take this to our notebook so that we can do it there. Classify these angles, yeah. Or no, I can also take this as well. Yeah, that should be good. Just give me a second. Okay, just as a piece of information. So if you remember last time we talked about algebra, the basic algebra, which is about expressions. We did the brackets expansion and a lot of different stuff about expressions. But anyway, just a small recall. Let's get to the new topic. Today we have some new stuff to do. And okay, so this is going to be our kind of a helping hand, all these angles. And now we have to classify these angles. So how do we classify them? So this one, this looks like an obtuse angle. Again, obtuse is between 90 and 180. You can see it here, obtuse angle. Next one we have, this is a reflex angle between 180 and 360. So anything between the 180 and 360 is called a reflex angle. And also we have a right angle. Okay, that's about it when it comes to classification of angles. Let's get to the new topic. I think I'm gonna erase it here because we have it there. So I'm gonna keep my book clean. You can draw an angle using a protractor. Well, we know this, right? I draw the following angles using a protractor. Okay, so for this question, I think I'm actually gonna use an app that I just found for drawing angles because it has a protractor in it. So I'm gonna try it out. I hope it works fine. Yeah, so this way we can have, yeah, this is where we're gonna have the question. So draw the following angles using a protractor. We have 60 degrees. So let's do this. Let's draw the 60 degrees one. So A is 60 degrees. I have a protractor here. And the way we should do this is actually we also need a ruler as well. So we need a protractor and we need a ruler for this task. So first thing you do is you draw a straight line to draw an angle, 60 degrees. Let's draw a straight line here. The line can be as long as you want, not too small, not too long so that you can see it, and yeah, maybe 5 centimeters is fine. So I'm just gonna draw 5 centimeters here, a 5 centimeter line, and then I go protractor. Okay, so this part is important, so pay attention. I think I draw it a bit too high. I will make it. Oh my goodness, this app is annoying a little bit. I think I'm gonna just do it here. So anyway, 60 degrees. One more time. So we go like this, 5 centimeter line. Can be 6, can be more, up to you. Try to make it straight. And now we have to take a protractor. Let's do it again. And so, okay, so this is important. You see on the protractor, you have this line here. So what you have to do is you have to align this line on a protractor with your actual line on paper. Or maybe if you're using an iPad, then on iPad like me. So what you have to do is you have to try to find the beginning of this line and align it like this. You see, so that the beginning of this line is going to be right here. Yeah, this is important. And now, so what we have to do next is we have to find 60. We have to find 60. It can be a little bit puzzling because you see on this protractor they have 60 here, there is 60 here, and also there is 60 here as well. I hope you can see the cursor. So which one do we have to use? Again, we have to remember that the angle 60 is acute angle, less than 90 degrees. So if we use this 60, it's probably going to be more than 90. Just think about the shape we will have. We will have this kind of shape, right? And this is not what we need. We don't need obtuse angle. We need a acute angle, right? So this is not what's going to work. So we have to use, or I mean this cross line. Yeah, you actually have to do it like this. Actually, it has to be here. This cross is what you have to align with your beginning of line. So like this. Yeah. You have to put it like this. Align it carefully. And then next to 60, where you have your 60, which is here, right? You have to draw a point. You can put a point on here. let's just put a small point here, okay? Now you throw away your protractor, or I mean just put it away, maybe we're gonna need it later. And what you do is you draw a line from the beginning of your line to this point. You draw a line like this. That's it. This is our angle of 60 degrees. Okay, it's a pretty time-consuming operation on an iPad, so I think I'm gonna go to the next question. I hope this makes sense to you. Oh, okay, let's do one more. Let's do F. So this is A. This is A 60 degrees. A 60 degrees. I think I'm gonna write it in the notes. Yeah, like this. I think I can just make a screenshot. And I will put it in the notes. So this is how we draw a 60 degrees angle. And next, let's try something more complicated. Let's try something more complicated. So it gets complicated when you have to draw a reflex angles. That is a little bit complicated, so I'll try to show you how to do that. Let's clean it all. Ruler, protractor. Okay, so again, we had this thing in here. So 270 degrees. We want to draw 270 degrees. How do we do that? So if you notice on this protractor, we don't really have this angle. We don't even have 270 degrees on the protractor. So the way we should do this is we should express 270 as a sum of 180 and something else, whatever is there. So 270 is equal to 180 plus, and here what you can do is you can do 270 minus 180. So 180 plus 90 degrees. This is your 270. And so these angles, this is something we actually have. We can draw 180 degrees, which is just a straight line basically, right? So let's draw this. This is our 180 degrees angle. I can try to show you this. So this is 180 degrees. And then what we have to do is we have to keep going behind that. We have to keep going behind 180. Let me change the color. So we start here, right? We go, this is 180, but this is not what we need. We need more. We need 90 degrees more, right? Plus 90 degrees. So what we have to do is we have to take the protractor, we have to turn it upside down. We have to turn it upside down, and we have to measure. Again, try to find the center of this line, and we have to measure 90 degrees here. So we find 90, like this. And now what we have to do is we have to draw a line here. So try not to look too much on the black line. Our actual angle, our actual 270 degrees angle is going to be these two red lines. This is our 270 degrees angle. Let me show you this. So this 180 plus 90, so 180 plus 90 gives you 270 degrees, like this. So it's a little bit complicated to draw a reflex angle, but I'm sure you guys can do it. Just give it a little bit of practice, it's going to work out. So what you can do is you can try to finish this exercise. Again, if you have some free time, you can try to practice this. It's an important topic which will be used often, drawing angles, measuring angles. I mean, not that often, but you will definitely see it in in the next years, in the years to come, you will see this topic. So you have 200, you can try this, you can try 200 degrees, you can try 160 degrees, and you can try 150 degrees. So you can just pause the video, or you can just do this as a homework for you. Okay, and next is we have to use the protractor to measure these angles. We have A and B. Okay, so I will try to copy them. I think I will have to just make a screenshot and then copy them to that app. So we have this angle A. Basically, measuring angles is an opposite procedure to drawing angles. I'll try to show you what I mean. Let's clean it all. I hope I can do it. No, not really. They should have it somewhere here. Yeah, okay, it's a little bit, it's a bit big, I would say, and I don't know why is it on this side. Okay, wait, let me try this again. Okay, not the best app, to be honest. But so the way to do this, I'll try to do it here. The way to do this is you go to the beginning of the angle, like this, and again you use this intersection of these two lines, right? And you try to align it with the center of your angle, like this. So you try to align this point right here, and you try to align this point right here, this point. Let's do this. So we go and we try to align them like this. Yeah. And you can see that this angle is somewhere between 50 and 60. This protractor is not super clean, but I think I can see it's something like 53, I think, is going to be the closest measure. So this angle is equal to, I can draw it here, this is 53 degrees. Okay, I hope it makes sense, kind of. Yeah. And let's try another one. We have B here. Okay, I think I know how I should do the screenshot. I need to leave a little bit of space on the left, like this. Maybe this way it's gonna be better. Oh yeah. Yeah, that's definitely more workable with, I would say. So we take a protractor again, and this is, okay, so this one is a bit tricky. Again, we have two numbers. I forgot to mention it last time. There's two numbers in here, as you can see. So it can be 55, 54, or it can be 126, I think. So the way we have to do this is we have to think what type of angle is this, and in this case this is a reflex angle. It's reflex, right? And reflex angle is between 90 and 180, so don't forget about that. I have to, is there an eraser here? Yeah. Oh my goodness. Yeah, this is a bit strange. This eraser is a bit strange. Okay, so this angle is a reflex angle, so it's between 90 and 180, which means that we have to use this scale. It's going to be 126. So 126, I would just leave it here, I think it's fine. here, right? From 0 to 126 is this angle. Why is it so big? (126°). Okay, so this is how we measure angles, and let's get to the next one. Okay, 1, 2, 3, 4. Triangles can be classified according to their sides. So one more thing to remember, there is an equilateral triangle with all 3 sides equal. There's an isosceles one with 2 sides equal, and also 2 angles are going to be equal as well. And don't forget about this. So if three sides equal also means that all 3 angles are equal. 2 sides equal, it means that those two angles here are going to be equal, this and this angle. And scalene means that no sides are equal. And we can take a look at the triangles here. Equilateral, which triangles are equilateral, which triangles are isosceles, which triangles are scalene. So the way we can do this is normally we would have to use a ruler to do this question. I can try to go to that app again. Okay, let's try this. Let's try to do it in that app. I don't really like it much, but let's do it. Yeah, so which triangles are equilateral? So you have to take your ruler actually, and we have to think about this. Which, like, first equilateral, so there is only one of them which kind of looks like all sides could be equal. It's C, right? It kind of looks like the equilateral one. So we can try and check its measurements. So we do it like this. And this is 2.7. This is 2.7. This is 2.6, 2.7. I guess we can forgive them that. It's pretty close. And just the third side left. Also 2.7. So my eyes, they do not betray me. Sometimes they do, but this time not. So this one is equilateral. So this triangle C is equilateral. We can write this. So C is equilateral. Isosceles. So we have A and D here. They look like they are isosceles. F, not really. I wouldn't say so, but maybe. We can try it. We can try everything. So we try A. Let's try it. So here we have 3.5 at 3.5, and then we can go to the other side like this. And this is also 3.5. So A is, oh, I think I accidentally erased it, right? So C is equilateral, A is isosceles because 2 sides are equal, right? We just found it out, so that this side and this side, they're equal. Here all 3 sides are equal. And we can try D as well. It also looks like it's kind of looks like it's isosceles, right? Yeah, it's 4.5, and here is 4.5. So D is as well isosceles. D is isosceles as well. We can try F. I mean, let's try it. F is probably not going to be isosceles. So this is 3.4, and this is 3.8 or 3.7, something like that. So this is not isosceles. And the rest of them, the other triangles, they don't even look like they could be isosceles. So F, E, and B, they are just scalene, so it means they have no equal sides whatsoever. Okay, I think that's it for this lesson. We can continue it next time. Bye bye.